Hi students, this is Ms. Medina, and in this video we're going to talk about the end behavior of linear functions and other functions after we talk about the linear functions. The end behavior vocabulary. To describe end behavior, you have to describe two things: which direction the x values are growing and which direction the function or the actual graph is going. So right here in the middle, we have right and left. Your x can grow to the right. That means it's going to get more and more positive. We say that as x approaches, that's what this little arrow means, as x approaches positive infinity. That means that x is growing positively or on the right, in the right-hand direction. X can also become more and more negative. Right, if we're talking about the behavior of the function on the left-hand side, and we write that as x is approaching negative infinity. That means your x values are getting more negative and more negative. The function can be doing about three different things. One of them is slowly rising up, right? Or your y values could be slowly going down. Right, to describe a function moving up, there's only one way. The function is moving up, or the y values are becoming more and more positive. You would say f of x, or the function, is approaching, that's the arrow, positive infinity. I see whether it's yellow or blue, it's the same notation because you're saying the same thing. The function is going up, or the function is getting more positive, or the y values are getting more positive. Right? If the function or the y values are becoming more negative, right, whether you're going to the right or to the left, we say the function is approaching negative infinity, right? Whether you're in the right side or the left side, the function is approaching negative infinity. That means the function is going down. All right, let me recap. To describe end behavior, you have to describe two things: in which direction your x values are growing, and then what is the function doing. Let's look at a picture or a graph. This is a line, f of x equals 2x plus 1. We're not quite there yet, but what I want you to notice is that as your x values become more positive, the function or the y values keep on rising. They become more and more positive. Same thing here, as your x becomes more and more negative, the y values or your function becomes even more and more negative. So how do we describe this end behavior? All right, so to say that on the right-hand side, the function values are getting more and more positive, we say as x is approaching positive infinity, the function f of x is approaching positive infinity. To describe that on the left-hand side, the function values are going down or becoming more negative, we say as your x values approach negative infinity, right, as they go to the left, the function values, f of x, is approaching negative infinity. And of course, you can rewind this if you want to listen to it again. All right, take a look at this function. So this is your right-hand side, and you can see as your x's are becoming more positive, the y values are going down. They're becoming more and more negative. On the left-hand side, as your x becomes more negative, the y values of the function rise. They're becoming more positive. So let's go. As x approaches positive infinity, the function is approaching negative infinity. As x is approaching negative infinity, the function is approaching positive infinity. Remember, x can only go in two directions, to the right or to the left. Right? So you have other functions, and some of them might look like this. This is still the right-hand side, that's still the left-hand side. In this case, this function is rising on both the right side and the left side. Well, first you say as x is approaching positive infinity, the function is approaching positive infinity. As x is approaching negative infinity, the function is approaching positive infinity. And you can have different types of behaviors. Asymptotic end behavior. Asymptote is, this red line right here, is a line that a function approaches but never reaches. And so this function right here on the left-hand side, you see as x becomes more negative, the function is going down. So right here we read end behavior. As x approaches negative infinity, the y values approach negative infinity. They're going down. But on the right-hand side, the function is not going down and the function is not going up. It seems to be slowly approaching this red line. And if we trace this for many x values, you will notice that it'll never reach the red line. It'll just get infinitely closer. So how do we describe this behavior? We say as x is approaching positive infinity, so as x gets more positive, the y values of the function become closer and closer to 1. So the function approaches 1. And of course, we have different types of asymptotic behaviors. Once again, it's a line that a graph approaches but does not intersect. So we can have horizontal asymptotes, vertical asymptotes, or even oblique or slanted asymptotes.